right, these are the answers to page 612. The first three just want us to show that these diverge. Number 9 is a geometric series with r greater than 1, and therefore the terms will get bigger and bigger and bigger and bigger, and so it diverges. You could even say by nth term test, because the nth term of this will not go to 0. So it won't get through that screener even to us. For 12, same thing. If I take the limit of n over 2n plus 3 as n goes to infinity, I'm going to get 1/2. So that means the sequence itself will become 1/2 over time, and I'll continually add 1/2, 1/2, 1/2. So this diverges by nth term test. All right, and then for 15, we have 2n plus 1 over 2n plus this. So if I were to maybe kind of rework this out, over time, this plus 1 really isn't going to matter. It's really going to be this right here that makes a difference. And you could see that this 2n over 2n plus 1, I could pull a 2 off. I could write this as 2 over 2 to the n, and then I could have another 2 down here. Now again, I'm ignoring the plus 1 for a second, because over time it really isn't going to matter that you added 1 more to the top. These numbers are going to be so big. And so this right here becomes 1, and so this whole thing will eventually gravitate to a 1/2. Again, because of the 2 to the n over 2 to the n, that's going to kind of neutralize, and so we're going to have terms that are basically 1/2, 1/2, 1/2. And for the same reason as 12, then this diverges by nth term test. We don't have terms getting smaller and smaller and smaller. We have them getting closer and closer to 1/2. Okay. 17 and 21 want you to see which partial sum you get. So I went ahead and I put 0 in, I got 9/4. Then when I put 1 in, I got 9/16. So that would be 9/4 plus 9/16. Then I put another one and got 9/4. And so this is getting closer and closer to 9/4 over 1 minus 1/4, which is 9/4 over 3/4, or times 4/3, which should give us closer and closer to 3. So it should be something between 2 and 3 to start with, and then getting closer and closer and eventually equaling that 3 there. Similar idea here. We have something that starts at 17/3, so it should be a little bit bigger than 5, okay, but not 6, so somewhere in there, okay. And as you do this, we end up with something that's 17/3 over 1 minus negative 1/2. So that's 17/3 over 3/2, which is the same as 2/3. That gives us 34/9. All right, and 34/9 is something that is just under 4. So this should be getting smaller, smaller, kind of coming something close to 34/9 as a limit. Okay, it goes up and down and up and down, and it eventually should gravitate there. 27 just wanted us to say why this converges. It's a geometric with r less than 1. So we not only know that this does converge, we know exactly what it converges to. It converges to the first term over 1 minus the common. And if you did that, that's 1 over 0.1, which is 10. So we actually know what that actually equals. Same thing for 40. If I were to put 0 in, I'm going to get 6 as my first term over 1 minus the common ratio. That's 6 over 1/5, which is 30. So these geometric sums that have an r value less than 1, we not only know they converge, but we know what they converge to. Similar idea on 44, we have 8 plus 6. To get from 8 to 6, we multiply by 3/4. To get from 6 to 9/2, we multiply by 3/4. To get from here to here, we multiply by 3/4 is our common ratio. So this is going to be our first term over 1 minus the common ratio, which is then 8 divided by 1/4, which is 32. 46, to get from term to term to term, you multiply by negative 1/2. And so this is going to be first term over 1 minus the common ratio. So that's 4 over 3/2, which if you flip it over, it gives us 8/3. And then these last three here just ask us to determine whether these converge or diverge. For 57, if you took the limit as n goes to infinity of this, you're going to get 1/10. And so the sequence does not go to 0. You'll continually add 1/10, 1/10, 1/10, 1/10 forever and ever. So this diverges by nth term test. This is a geometric. R is 1/4, so it converges. If we wanted to know what it converges to, we could put 0 in and find the first term over 1 minus 1/4. We'd actually get it. This here, e to the negative n, is the same as 1 over e to the n. All right, so this is also geometric. R is equal to 1 over e, which is less than 1, so it converges.